This Amateur Radio Roundtable is brought to you in part by ICOM America. Okay, hello everybody out there. Today is Tuesday, October 30th. It's Halloween here. You're listening to and watching Amateur Radio Roundtable. I'm Tom Edlin, W5KUB. We're coming to you from Collierville, Tennessee, right on the very left end of Tennessee, near the Mississippi River tonight. Our show is our audio is being simulcast on international shortwave station WBCQ on 5130 kilohertz. And we've got listeners in different countries. And hey, if you're listening out there tonight, send us a signal report. Send that to tom@w5kub.com. tom@w5kub.com. And we'll be glad to hear from you. Also, I just wonder, are there any new people, first timers watching tonight or in the chat room? If you are, say something in the chat room. Let us see who's here. And if you are listening on international shortwave station, if you have internet capability, you can go to w5kub.com and you can watch the show and join us in the chat room there. Tonight it's Halloween here in Collierville, Tennessee. Normally Halloween is tomorrow night, but we're expecting some very severe weather through here tomorrow afternoon. So the trick-or-treaters are out tonight. And they're already hitting the door out here. Kathy is manning the door and giving away the candy. I've already gone through the candy bowl there and picked out all the candy I wanted. We're going to give them the stuff I don't want, Hey, I've got a little video here of maybe a couple of Halloweens ago I shot. This is something I play with. We always try to make something different or unique, and you probably have seen this before, but this is us with the toilet paper roll on the air blower. So take a look at this. This is a couple years ago. So, guys, that's kind of some of the fun we have on Halloween here. We wrap them up like mummies. We wrap them up like mummies with toilet paper. The problem is the kids then walk down the street, and that toilet paper ends all up and down the streets, man. So, can you imagine 15 or 20 rolls of toilet paper up and down your street? It's pretty bad, man. But we had a good time with it anyway. Hey, tonight we got a special show tonight. We're going to be talking about EME and how to do it, and maybe how to do it on a budget, and it doesn't take a lot of equipment. We'll get that in a little while. But first, I want to bring in our friend Rich Mosen, W2VU, from CQ Magazine, and let's talk just a couple minutes about next month's CQ Magazine. So, hey, Rich, how you doing?
I'm doing great, Tom, and hope all your viewers and listeners out there are too. And before we get to next month's CQ, I've mentioned that this month's CQ has an EME station on the cover, so it ties right in. This is VA3 ELE, who was doing a one-man Grid D expedition up in Zone 2 in northern Quebec. Very cool operation. A lot of the EME is part of it. Moving to November, we've got a lot of great stuff. I have fun with the November issue because it's in between our emergency communication special in October and our technology special in December. So it gives us an opportunity to do a lot of mix and match and all sorts of different things. We start out with the results of two very different types of ham radio competitions. Start out with our own CQWPX CW contest results. And a less traditional report on the results of the amateur radio direction finding world championships, which were held in Korea this past summer. So that was a lot of, and the U.S. won more medals than ever in that competition. So it's an interesting story. A couple of really interesting pieces on one on QSL cards as amateur radio's postal history. The author is encouraging people not to be too quick to give up on paper QSLs because they represent a lot of our memories and then collective memories going back in time as we look back over our own ham careers and other people's as well. Really, really interesting perspective piece from our friend Vlado Z35M, who has written for us several times on QRP and operating in the field and stuff like that. And this is on amateur radio in Eastern Europe under communism and afterwards, and the differences between the two eras. He's from Macedonia, which is a former Yugoslav republic, and it's a very, very interesting look at the differences between amateur radio back in the communist era and today, with some surprising observations. No, I was definitely surprised at some of what I read. Of course, we've got some good projects in the issue. WA9PYH has an article on building a Raspberry Pi 3 pan adapter. And we're seeing more and more articles on ham-related projects to do with a Raspberry Pi or an Arduino. That's really where our technology is heading. We're going to see more of that in our technology special in December. A couple of antenna projects. K5QY has an article on building an optimized 40 through 10 meter off-center fed dipole. Saves some space and gives you multiple bands at the same time. And then for VHF, WB9ZIZ has a Tetra Beam, a $10 directional antenna for your 2 meter handheld. Also a very interesting, very budget conscious antenna that helps point your signal a little bit better. And on the general topic of antennas, our learning curve columnist, KO0Z, has a beginner's piece on antennas titled One Size Does Not Fit All, covering the basics of how you know what's right in terms of an antenna for a particular band or frequency. Our cover story this month is another really fun story. We call it a blast from the past, W9IOP's second op. This was a DXing tool from before the days of the internet, and it has a very, very close connection with CQ's early days. So that's a really very, very interesting piece, and a lot of fun, a lot of connections with the early days of CQ, which, by the way, we are finishing up our 74th year of publication with our December issue. So coming up very fast on our 75th anniversary in 2020. In some of our other columns, emergency communications editor Walt Palmer, W4ALT, writes about first informers, which is kind of a variation on first responders. The concept is first applied to broadcasters and the people who keep broadcast transmitters up and running, even in a disaster. And he's talking about the possible expansion of that theory to include amateurs who keep repeaters and such up and running as well, to be considered first informers. We've got a preview of WSJTX version 2.0, which is the umbrella software under which FT8 resides. And I have a feeling Pat's going to be talking a little bit about FT8 in his EME presentation, even though I haven't pre-discussed it with him. And because that's revolutionizing, or FSK 441, one of those. But the whole WSJT package started out as software for doing moon bounce and meteor scatter, and has expanded to cover a whole lot more than that. So we have a preview of version 2, which is really a big improvement in or addition of new features in FT8 and other parts of that package. In our DX column this month, we have a guest columnist, Jeff Cantor, K1ZN, who writes all about the Islands on the Air program. Many of you have heard of it. Some of you maybe have exchanged, have received an IOTA number, or maybe worked an IOTA expedition, but maybe not all that familiar with really what the program is about. And it's the grandfather of all of the OTA programs out there, from lighthouses to national parks to castles and forests. The first OTA program was IOTA, Islands on the Air, and Jeff has a great primer on that in our DX column this month. And finally, in a demonstration of how things can change quickly in the world of propagation, our propagation column in November is titled Poor to Fair Conditions Predicted for the CQ Worldwide DX-CW Contest. But we just got an update from Thomas Hood in W7US, our propagation editor, with his December column, which just came in. And looking at the sun 27 days out, he says, no, it's going to be good. It's going to be really good. So we'll see what actually happens. Now, last weekend was the CQ Worldwide phone contest, and the predictions a month out from that were that it wasn't going to be so great, but it turned out to be pretty decent, at least from my perspective. And I know 15 meters was really hot for a lot of the contest period. So hopefully we will be able to make our own propagation even if the sun doesn't cooperate, and have a lot of good DX going in the CW weekend at the end of November, just like we did this past weekend for the phone contest. And that's about it.
Well, it sounds like you got a lot of things going on there. And let's see, there was a couple of points I want to make. Hey, I like the cover. We're going to be talking about EME tonight. I'm looking forward to reading that CQ and see what they have to say in there about EME. And also,
that's the October cover, by the way.
Yeah, you're talking about, we've had a lot of programs here about the Arduino and all the things that it will do. And I've got a project right now I'm beta testing. It's a remote shack station using a Raspberry Pi. And we talked a little about it last week, and man, it is hot. It will. I can't say much about it. It'll run all digital modes. You can do it remotely. It's got the logbook in it, call lookup, everything, man. And it'll work. It'll work on any operating system, whether it's Mac, iOS or Windows or Linux. It'll work on any of them. So that's the nice thing about it. So we're going to talk a little bit more about that probably later. But in the beta testing, I got really down into it this week. But you're right. Things like the Raspberry Pi and Arduino are taking over, man. We got to start learning that, Rich.
That's right. It's actually a point that I'm making in my December editorial, which I'm in the middle of writing right now. But that's where our future is heading, in a great respect. We've have these platforms that have been made available to some very innovative people, both in and out of ham radio. But the hams who understand coding and understand, computer coding as opposed to Morse code. They've been unleashed to just let their creativity run wild and create all sorts of great ham shack accessories and transceivers as well. I mean, you look at something like the BidX transceivers, which are very, very popular. Mm-hmm. They're all based on Arduinos. And we have this Raspberry Pi article in here. We've got another one or two in December. We've started a microcontrollers in amateur radio column earlier this year. So it's going to be a major part of the hobby going forward. And I think that we as amateurs have a responsibility, even if that we're not into building stuff with microcomputers or into FT8 and stuff like that. We have a responsibility to know about it, to learn about it. We're supposed to be technological leaders in our communities, and it's our collective responsibility to be up on these developments and to know what's going on, to understand how they work.
I've got a lot of learning to
programs
do.
like yours and magazines like ours all help with that, and we need to encourage it.
Well, I've got a lot of learning to do, and you're right. That stuff's going to be taking over ham radio over the next years to come. You know, back, Rich, when we got our license, you know, the newest invention back then, in the early 60s, the newest invention was a ballpoint pen that would write on the moon. You know?
Yep.
Probably spent $1 million to develop that thing. I understand the Russians just used a pencil in their spaceship, but, you know, we had an ink pen that would actually write, you know, with no gravity, man. But that's the kind of technology we had back in the olden days, you know. But man, hey, it's exciting now with all the new stuff, man.
And it's, you know, it's helping with budget-minded projects, and which hams have always loved. But even the commercial stuff that's coming out there is incorporating this kind of concept more and more into it. Almost every new radio that comes out today from the major manufacturers is software defined in some fashion. And speaking of that, we're going to have a great piece in December, really explaining what software defined radio is and how it works. I learned a lot from reading and editing it, and I'm sure that our readers will also appreciate it. And of course, you can find CQ on our website, either the print or digital edition. You can sign up at www.cq-amateur-radio.com. And we're always happy to have new subscribers as well as keeping our current ones. And thankfully, most of our current subscribers love what they get every month.
All right. Well, Rich, we thank you so much for bringing it to us tonight.
My pleasure.
We will say 73. I won't say 73s. That's a different topic for us to get into one night, you know. Let's have a show one night on 73s versus 73. I can go either way with it, but man,
well,
some
you
people...
you then have to go with best 73s,
yeah,
which translates out to best wishes.
Yeah, oh yeah, man. Anyway, we'll have a show on just that topic one night. In fact, we had a little blip about that specific topic here a couple years ago in here, and it was funny. We'll see you. 73, right. Rich, thanks a lot for coming in, man, and sharing with us next month's magazine.
Okay, good night.
Good night. All right, so that was pretty interesting. The CQ magazine tonight is going to lead right into one of the subjects we're going to talk about tonight, the EME, and I'm going to bring in our 50 megahertz and above guy, Pat, shouting K7 LNP. I remember that as low noise preamplifier. That's how I can remember it. How you doing, Pat, tonight?
Doing real good, Tom. How about you?
Doing real good, man. So you're going to tell us all we need to know tonight, right? We don't have to go out and spend $50,000 on a station to make EME contacts, do we?
Only 40.
Only 40,000. I hope $40 to get it. You know.
Yeah. Well, yeah, maybe. I don't know. There's plenty of surplus stuff out there, but no. We're what I put together, Tom, tonight is kind of a kickoff point. I've got a PowerPoint presentation that's quite a few pages, but we're just going to use it for a little bit of reference and some notes, and sometimes a picture is worth 1,000 words, or maybe 40 or 50,000 words. And there's so much to discuss and cover. I don't want to put everybody to sleep and oversaturate, but we'll start out with this overview, kind of I don't want to call it a 50,000 foot level overview, maybe a 10,000 foot level overview, and then in shows to come and segments to come, excuse me, we'll go ahead and we'll expound on different things and on different pieces. And the thing that's cool about building yourself a setup for EME or for weak signal work is that you don't only use it for moon bounce. I mean, the moon is only available a short period of time out of every month. It can be used for tropo work. It can be used for weak signal work, for meteor scatter. Satellite antennas can be incorporated into the antenna system, and so it's going to be good. We're going to talk about all kinds of different things down the road, amplifiers and preamps and all kinds of stuff, and wiring up your shack. And but I figured this would be a good place to start tonight to kind of lay the groundwork, and we'll go from there, if that sounds good to you.
Yeah, let's get started and jump right into this. And just let
Okay,
let me ask real quick. Hey, if you're new to the show or new to the chat room, let us know in the chat room that you're new tonight. We'd like to welcome you. And what was that? You had what was the candle?
Scary candle, Halloween candle.
Oh, your Halloween. I can't.
There you go.
Is it supposed to be scary? I can't tell how scary.
Yeah, it scared me. I don't know.
Okay.
Anyway, happy Halloween.
All right.
Anyway, so if we're ready to get started, I'm going to go ahead and let's see. We got to share the screen here, I think. Let's see here. Let's get this pulled down. And Tom. And oh, that's crazy. Our screen share is gone.
Yeah, well, I'm seeing all your passwords right now to your bank account and everything.
Oh, there we go. How's that look? That a little bit better?
Actually, hang on a second. I can get it in there. I can make it, I think. Watch this. How's that right there?
There we go. There we go. So you can see it. You can see it now.
Yeah.
All right. Well, we're gonna have a little bit of fun and talk about some different things. It's going to be very informal, but I hope I can cover everything and at least get people thinking, maybe answer a few questions. So we'll start out with this beautiful looking moon. The one thing I want to, okay, why are we not switching screens? There we go.
I see the moon.
There we go. All right. First of all, I just want to say that in this presentation that I've put together, this is strictly for educational purposes. I'm going to talk about some different manufacturers, some different brands. I'm not endorsed by anybody. There's no payments or anything. I've used different pictures from different sites. I've pulled different information. Again, this is just for educating our audience. I want to also start out by thanking a few people. I know a few of them are definitely not here, but I got started in the weak signal world back in the early 80s, late 70s. And I had the opportunity to get some instruction and direction from quite a few people. And K1RQG, Joe, who lived up in Bucksport, Maine, big time pioneer in EME. Sadly, Joe's no longer with us. Paul into EME on the East Coast has helped me out, and John K9SST in the Midwest, and Doug W9IX, and many, many more. I want to just thank them for all the help that they gave me in my almost 40-year ham career in delving into weak signal work. What got me started, Tom and everybody, was I met a gentleman when I was a teenager by the name of John Flaws. His call was WB9VEM. And if you look on the screen there on the right-hand side, it says award number down at the bottom, 22. He was the 22nd recipient of the WAS 144 megahertz award. That is probably, I'll go out on a limb and say, more difficult than 5-band DXCC at that time. We had no internet. We had some HF nets. We had radios that were nowhere near the caliber that we have today. And I met John, myself being from Chicago. He lived in a little town called Hickory Hills, and he had a small house and this massive 8 antenna EME array. And I went and knocked on his door and asked him what it was all about. And we actually became good friends. Sadly, John passed away as well just a few years ago. But I was so impressed by the dedication of what he did, and he put this system together. It really intrigued me from the late 70s, and I've still had that same fire burning and intriguement since then, till this day. And I love to see people get involved with this. I think of all facets of the hobby. Earth, Moon, Earth is got to be one of the most interesting things out there. And again, I hope we can kind of give a little bit of flavor here to everybody and build a little bit of interest. So let's go ahead. Let's have some fun. Let's start talking about EME, and let's talk a little bit about the history of it. First of all, as far as history goes, it's the use of the moon as a passive communication satellite. It was calculated that with the available microwave power transmission of the day, and we're going to talk a little bit more about what the day means, and a low noise receiver, it would be possible to beam signals from the Earth and reflect them off the moon back. The term moon bounce, or this technique, was developed by the United States military in the years following World War II. It was then changed to communication moon relay, a project that would use EME or moon bounce to link the naval base at Pearl Harbor, Hawaii, and the United States Naval Headquarters in Washington, D.C. via the moon. The first gentleman that stepped in and kind of headed up this project was John H. Dewitt, Jr. John was he was alive from 1906 to January 25th, 1999. He was an American pioneer in radio broadcasting and radar astronomy. He became a ham in 1922. His call was N4CBC. And in 1924, he helped direct the design and installation of a 100-watt transmitter at the First Baptist Church in Nashville, Tennessee, which would become the area's first commercial radio station. He earned his degree in engineering at Vanderbilt University, and he was a lieutenant colonel in the United States Army. A military project was established in about 1944, and they tried to come up with a name for it. What's in a name? Well, they called it Project Diana, named after the Roman moon goddess Diana.
And hey, let me just say something.
Sure.
Yeah, we had an entire show on Project Diana about a year and a half ago, where we actually had a tour of the building and the facilities, and we talked all about that project. It was very interesting.
Very good. Very good. So hopefully there's some links or people can look back on that. Yeah, very interesting when I started digging into it. Again, I had interest in this type of communication, but when I started looking into where it came from, it was really, really interesting. For people who didn't see that, what was done at the time was the Project Diana effects were 3 kilowatts of power at 111 meg and quarter-second pulses. The first successful echo detection came on the 10th of January in 1946 at 11:58 a.m. local time. And then, of course, after that, the array was used to map Venus and other nearby planets. And at that time, 111 megahertz was considered a microwave frequency in 1946. I thought that was absolutely crazy. And when you look back at those documents and stuff, it talks about using the microwave band and at 111.5 meg. The original, here's a picture of the original Project Diana antenna array. It was 24 dB of gain, and it was a modified radar antenna. No elevation control. It had azimuth, and it had, when the moon was present, it had a 40-minute moon window. So pretty short period of time for communication. Here's the Project Diana site in 1946 at 4th Monmouth, New Jersey. The verification of the signal picture was taken. The large pulse on the left is the transmitted signal at 3 kW. The small pulse return on the right is the signal coming back from the moon. As they tweaked the system and developed the system, they eventually took it up to 50 kilowatts and had pretty, as long as the moon was present and they didn't have to elevate the array, had pretty consistent communication and pretty consistent success. Prior to that, which I found very interesting, is no one knew if signals could be sent into space and penetrate the Earth's atmosphere. That was really the first time that we ever tried that. The event paved the way for satellite technology as well as the moon landing programs, and truly history was made back in 1946. If you could copy that signal in any way, shape, or form in 46 or beyond, you could actually get a Diana Moon Radar QSL card, which I thought was really interesting. Here's the Project Diana site today. The dish is a 60-foot dish. It was built exclusively to track the Pioneer 5 spacecraft. And this is maybe one of the videos you're talking about, Tom. This is a very interesting video. The 70th year of that transmission, the Special Event Station N2MO went to the site, and they actually, at that same time, not at 111 megahertz, but I believe at 432 or either 1296, made the same transmission to replicate it. Very interesting videos by this group, and more history, of course, is talked about. The Monmouth Amateur Radio Club and Princeton University currently occupy the building, the radio equipment, and they maintain the site and the dish. And it's still working fine as of today, and it's still being used for EME and different celestial, I don't want to say interrogation, but research. I found this, I've actually reached out to this lady. I haven't gotten anything back, but Cindy had a web page, and I believe wrote a book. Her father was involved with Project Diana, and talks about all the different people that she interacted with when she was a young girl. The site is projectdiana-eme.com if you're interested in it. It's really a really interesting site. I'm hoping that she'll get back to us. She's located in Michigan, and would love to arrange something to maybe even have her on the show and talk a little bit more about it. But again, pretty interesting history when you start digging into it. All right, let's go ahead and get into the meat of 144 megahertz or 2 meter EME. Again, it's a two-way radio communication using VHF, using the moon as a reflector, and it's commonly known as moon bounce. EME for the radio amateur. In theory, if two stations have adequate equipment and can simultaneously see the moon, they should, and I should have put that in quotes, be able to make a contact via EME. Several attempts may be required to achieve this success. The signals are very weak echoes reflected from the moon's surface. They're usually at the noise level or even a little below the noise level, and then occasionally they rise from the noise level. There's plenty of challenges with this part of the hobby or this experimenting or form of communication. One is that it's an extremely long trip. The moon is at an average of 239,000 miles away from the Earth. Moon, on a moonless night, well, no moon, no EME. So again, we have a somewhat of a short window. Mixed up signals, and I want to talk a little bit about this, and we'll get into more detail in further shows. But a challenge is spatial polarization offset. Your horizontal isn't my horizontal, or my vertical isn't your vertical. When the signals are sent to the moon and they come back, depending on where they actually reflect back off the moon, they can get rotated up to 90 degrees. So you may have great moon conditions. You both may be able to see the moon, but due to, again, spatial polarization offsets, that may be a problem. But there are ways to get around that, and there are fixes with that. Of course, path loss is huge. I threw that big calculation in there. I've never sat down and put a calculator to it, but there it is. That's what will calculate it up. And of course, the challenge is that during the lunar month, the moon travels in a slightly elliptical orbit. It's 221,000 miles at perigee. At perigee means it's closest to the Earth. And at apogee, at 252 or 253,000 miles, is the furthest point from the Earth. When the signal goes to the moon and comes back, especially on 2 meters, there's about a 2.5 to 3 second delay. And of course, the round trip path loss is about 252, 253 dB at apogee at 2 meters. So there's a considerable amount of loss there and back. Noise, I would say, is probably our biggest problem, or a problem that many people have to deal with in many types of weak signal work. You've got local noise right behind my house. I live in a house that was built in the early 50s. And we don't have below ground power cables. I wish we did. We actually have something very similar to this picture right 25 feet out my back door. Surprisingly, the phone company and the electric company has come in and they've done some improvements. And all in all, unless it's really raining or if we're getting like a sleeting type of rain, it's pretty quiet for me. I was actually surprised when we moved into this home, which used to be a rental for us several years ago. I was really concerned that my ham radio days were going to be over. But all in all, not too bad. Another noise generator that I had in the other room was a plasma television. If anybody has a plasma TV, go ahead and throw it on and watch the noise level rise. While they'll give you a nice clear picture, they just generate a horrendous amount of hash. And of course, something like an old dishwasher, an old microwave. We had one not quite as old as this that we replaced, and I was amazed how when it went into the rinse cycle where it ran the pump or the heater, how much noise it generated. So there's a lot of noise that's just generated right around our homes that we have to contend with, and I would say that's one of the biggest factors. But it is definitely possible, without a doubt, and times have changed quite a bit. So let's talk a little bit about then and now in EME. Let's revisit a little bit. As far as antennas go in EME arrays, back in the 70s and 80s, Lyle, VE7BQH, who is, I would say, is a pioneer in 2-meter EME antenna, 2-meter antenna design, and also in helping people get involved with EME and his success, had this big 385 element collinear up. Lyle is no longer active. He used to run the Saturday and Sunday morning 2-meter EME net, but just an amazing antenna. Saw some pictures of his home in Canada, which wasn't all that big, with this massive array sitting over the top of it. Anybody who's looked or talked about or thought about EME and did any kind of digging into it, of course, Dave, W5UN, probably comes up the most. Dave now lives in Manville, Texas. No, he used to live in Manville, Texas, and now he's moved. And here's his current array. It's 32.5 wavelength antennas that have vertical and horizontal polarization. It was originally called the Mighty Big Array, and if you look at that picture, he used car chassis. He had the center mounted, and he used car chassis with electric motors that would turn the array around. It's a little bit smaller version right now, but again, a huge antenna setup. I don't know if my wife would allow that on. Well, I couldn't put it on my piece of property because it's about the size of my house, but a massive antenna. You can see the seriousness without a doubt by having something of this size out there for you. Another gentleman, OK2KKW, a massive EME array over in Europe. With, again, very good results. But today, something very similar to this will work just fine. A single Yagi, the one in the picture here is a little bit on the small side, but a single Yagi mounted on a little piece of wood or on a tripod or rotor. You can manually elevate it or manually turn it. Will actually work, and people are having quite good success. ZL1RS has a long boom Yagi up in New Zealand, and he's had very good success with this Yagi. He's running it pretty much in a portable configuration. It's in the backyard with some guy wires. It's manually moved around and pointed at the moon, and then when he's not using it, it's taken down. N1BUG has a single Yagi. It's built with ASL capabilities. He can turn it around and he can tip it up and down. That little box there is a mass-mounted preamp. Let's talk a little bit about transceivers of then and now. Back in the 70s and early 80s, I'm sure a lot of people that have experimented with sidebands, with 2-meter sideband or CW, would remember this, the old TS700, a great radio in its day and a very expensive radio in its day. All solid state. I actually have 2 of them left. I used them as I used them for IF radios to drive transverters. They take a while to stabilize and warm up, but again, a very nice radio. ICOM came out with a series of these little guys. These are little, they look like a book actually. The 202, 402, and 502 little 3-watt QRP radios. John Flaw's WB9VEM, which I mentioned in the beginning of the slideshow or presentation. This is what John used to get number 22 WAS on 144 megahertz. This driving a homebrew amplifier feeding 8 16-element Yagis up in the backyard. And of course, in the day, the KLM Multi 2700, a great radio, expensive radio, but an all mode nevertheless, and just performed very well. Even till this day, there's still a handful of guys that are using them. Not so much for weak signal or EME type of work, but I never owned one of these, but had the opportunity to play around with them. It's sort of a semi-synthesized radio, very ingenious in its day. And of course, before that, before those type of radios, people had like the Drake transverters, the TC2 or the TC6, the 2 and 6 meter transmitting converters, and on top the CC1, which housed the receiving converters. Again, in their day, this was state of the art, with the exception of the receiving converters that actually had new Vistors in them. The transmitting converters were all tube, and they worked with the Drake B line. And of course, today, here's what we have, which I'm saving my pennies for, is the new ICOM 9700. All these new SDR architecture radios are changing everything. It is just amazing when you look at the specs on this radio. Hopefully, we'll see this radio out in the not too distant future. And if it measures up to like the 7300 and the 7610, but for the VHF, UHF, and SHF spectrum, I think it's probably going to be the radio of choice for people that are involved in this part of the hobby. Very, very interesting looking radio. Let's talk about how do we communicate using EME. Before I go to this, Tom, any questions that you might have or anybody else might have? We're kind of covering a lot of grounds, and we're doing a little reminiscing between the days of past and the current days. But if there's any questions, I'd be glad to try to answer them, or we'll just keep going.
Yeah, let me see. There's been some discussion in the chat room there about it. I haven't seen any questions yet. So if you got questions, put them in the chat room. While we're at this time mark here, let's take just a quick break, and then we'll be right back. It's time to get the transceiver that's best suited for your lifestyle. ICOM offers a variety of high-performance and innovative products. See how you can make the most out of contest season with one of these transceivers. The competitive edge you've been looking for is in the IC7851. Raise the bar and hear what others cannot hear with this flagship HF 50 MHz transceiver. It has reciprocal mixing dynamic range, crystal clear local oscillator, spectrum scope, dual receivers, and a digital voice recorder. The IC7610 is the SDR every ham wants, and just in time for contesting season. This high-performance SDR has the ability to pick out the faintest of signals even in the presence of stronger adjacent signals. The new ICOM 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. It has direct RF sampling, 110 dB RMDR, an independent dual receiver, and dual digital select. The IC7300 has changed the way entry-level HF is designed. This high-performance, innovative HF transceiver with a compact design will far exceed your expectations. It has RF direct sampling, 15 discrete bandpass filters, a large 4.3-inch color touchscreen, real-time spectrum scope, and an SD memory card slot. Visit icomamerica.com/amateur for more information on ICOM radios. All right, we're back with Pat K7. LNP, low noise preamp, some way I can remember it. We're talking about EME. I think we're getting a little bit more modern today in what we can do. So Pat, let's go ahead and continue, and if there are questions, I'll try to jump in here and break in, okay?
Sure, sounds good. And again, this is to kind of cover the whole scope of it at a high level, and talk a little bit about where it's been and where it's gone to, and the challenges that it's had, and the challenges that still does exist. Moving forward, exchange of information. How do we communicate using Earth, Moon, Earth?
Well, hey, there is one question here.
Sure.
Brent is asking, do you need massive EIRP to get out? What sort of mount's the best, and so forth? Hey, I'm hearing that, just a single long Yagi, like a 14 element Yagi, and maybe 160 watts of power. The combination of those two makes it possible. What's your thoughts on that? And I'm sure you're going to get into that in a minute.
And we are. I would say you want an antenna that's going to produce somewhere in the ballpark of 14 to 15 dB a gain. Power-wise, 150 to 200 watts. 300 would be better. A couple Yagis would be better. But we'll talk about all that, and we'll also do a segment down the road where we talk about antennas and antenna design and stuff too.
Yeah, a high gains antenna I just ordered, the 14 element. It's a 15 dBi, which is 13 dB. Mm-hmm. So I'm planning on that, and maybe an amplifier, maybe 150, 200 watts. So that's going to be my setup. Go right ahead.
Well, and the thing too, of course, is that when we looked at some of these other stations back a few slides. There's quite a few people that are, with big arrays that are still very, very active. W5UN, Dave is still very active. OK2KKW is active. There's a lot of guys out there that are using big arrays, and you'll be able to work them. I mean, there have been some people that have, we're going to get into the software part of this whole thing, but there's people there are single Yagi to single Yagi communications going on. And again, of course, moon conditions and all kinds of other things come into play. We'll talk about that. Even having a couple of big arrays, sometimes you don't make it. It's just like it's like DXing. You may hear somebody at 40 over, and you could have the amp cranked up and the beam turned, and they don't hear you. So that's kind of the challenge of the game. But I would say at least a 14, 15 element long boom Yagi and 150, 180 watts, something like that. And I would say that you've got a good chance at it, without a doubt. So getting back to how we communicate, again, back in the 70s, 80s, 90s, even just up until a few years ago, we used Morse code. Now, the big stations, the W5UNs, some of the higher frequency EME operators that have dishes and what have you, can use sideband. The Diana Project video with 432 and 1296, they're actually communicating with a couple of big stations in Europe using sideband, talking almost like you and me are talking here, Tom. It's absolutely amazing. But again, for the most part, CW was what everybody used. Now we use a digital mode, and as Rich alluded to, which is going to be good in CQ Magazine, is going to talk more and more about the WSJT suite, and we're going to talk about that here as well. Everything changed when the digital age arrived a few years ago for ham radio. It was in 2013, something wonderful does happen and did happen, and that is the invention of JT65. JT65 came on the scene. Joe Taylor, I call him a miracle worker, and I would also like to hopefully someday get Joe on Roundtable with us. Joe came up with software that was designed to decode and work with this extreme weak signal mode. Of course, a little bit about Joe. He's an American astrophysicist. He's a Nobel Prize winner. He is a professor at, I'm not sure if he's retired. He was a professor at Princeton for many years. You can go out to his website, just do a search on K1JT anywhere, and it'll bring you to the Princeton EDU site, and you can go on that site and take a look. You can download the software for free. The WSJT package has many, many different software modes underneath it. JT65 is just one of them. Again, down the road we'll get into more of them. 65 for EME worked out really well, and Joe developed it, plus many other developers contributed to it, because one, it can decode signals below minus 31 dB, and I think that number's even getting higher now. CW is only copyable to about minus 12, and I'm not putting CW down in no shape or form, because there's still a lot of guys that use CW in the weak signal modes. But again, the computer with JT65 running is a formidable foe. It's an amazing piece of software. The program is very stable. Doesn't need to be executing on an expensive processor. It's all open source. There are many developers that are out there working on the product all the time, and there's several new builds and updates coming through almost monthly, in some cases weekly. And of course, the big thing is it's free. There's no charge whatsoever. Survey says JT65B for EME, by far the most used and most reliable mode, is JT65 for readability of signals with respect to noise. I would say, I'll go out on a limb and say that 90-95% of all EME QSOs on 2 meters are performed using the JT65B mode. Again, there are some people that are using some other modes. Sideband, of course, if you have a station that's capable of that, or there's still some people that are using good old CW. One thing I like about the JT65 and everything that Joe puts together is the amount of support that he offers on the website as far as setting up the software. It's very easy to understand. Again, so many people have developed into this mode and into these digital modes and this software. There's forums galore out there, but it is actually pretty straightforward right on K1JT's site to be able to get yourself up and running. The program is not that big. You can download it, rips down pretty doggone quick. And again, you can go out and take a look at all the alterations, all the different builds and the changes that have been made. And it's changing, again, Tom, almost on a weekly basis. All right, let's get into the meat of things. Let's talk about what we need. What do we need to get started? First of all, I will go out and say that if you're going to try this, if you're going to give this a try, put together the best station you can. That doesn't mean go out and spend $40,000-$50,000 like we were joking, but put together, if you're serious enough about it and you want to have some success, go ahead and invest in it. Even if it takes a little bit of time. My station is always evolving and moving forward, and when I see something new like the 9700, I would love one. But gonna have to save my pennies for it. Gonna have to put a little bit of money away. Gonna have to get rid of some other things. But try to go ahead and move forward and go with the best equipment you possibly can. Also, as I mentioned before, once you build your station up, not only do you use it for Earth, Moon, Earth, but you can use it for meteor scatter work, satellite work, as you've done, Tom, and weak signal work, tropospheric ducting. Here where I live in the Intermountain West, at the altitude I'm at, and having 2 giant mountain ranges on either side, for me it's either work the locals or satellite or EME or meteor scatter. And that was why when I moved to Salt Lake some 20-some years ago, I really stepped up my game, because again, I lived in the Midwest. I was able to take advantage of a lot of the different propagation modes that were back there for the higher frequencies, and when I came here, that just didn't exist anymore. There's really no tropo up at 5,000 feet, unfortunately. Let's talk about the transceivers. First of all, you need a multi-mode transceiver that's capable of working on 144 megahertz, and there's so many radios out there that are. There's the ICOM 7000, the old 706s, is it the 7100, the one with the slanted face? A lot of those radios are 160 through 432 or for 450, but they're multi-mode. They'll work on sideband and CW as well. You need a radio that's capable of sideband and CW, but you need a radio that's very frequency and VFO stable. You can't have something that's drifting around. When we look back at the Kenwood radios and the old KLM radios, there are things that can be done to stabilize those radios. They can be left on for a while and they tend to calm down. But you have to have a radio that really is not moving all over the place. The better the filtering and the stability, the better things are going to work in your favor and you're going to have success. The digital modes require that everybody is synced up together, and timing is really everything. You need to have an accurate computer clock because, again, when you're transmitting, we're transmitting in sequences. One person is transmitting, one person is receiving. Then, of course, it switches. They receive and you transmit, and vice versa. And if you end up having a computer clock that's off more than about a second and a half, you may not even get the decodes. And that really holds true even for FT8 and stuff like that. I know sometimes you'll see people out there, if you look on your FT8 screen, you'll see the deviation, the time deviation. But there are things that you can use that don't cost you any money. Something that I've had very good luck with is this piece of software that's up on the screen called Dimension 4. Dimension 4 is free, and what it does is it actually polls different server sites around the world. When it polls them all, it actually creates a time constant, and then it goes ahead and it updates your clock in your computer. I found this to work very well. It just works, and I don't seem to have an issue at all with it. And again, it's required for not only JT65, but MSK144, FT8, all the other digital modes. Really need to make sure that everybody is synced up together time-wise. Of course, you're going to need some interfacing for the radio and a computer. Here's a very simple, for people that are using FT8 or PSK31 or any of the digital modes or RTTY, same thing. Again, a computer, an interface. The radio, of course, needs to have 2 meters on it, sideband. A little drawing there has a solid-state PA and an LNA and an antenna and some control cables. There's a little bit more to it, but high level, that's what it takes. The interface keys the radio puts out the signal, vice versa. The signals need to be clean. In order to participate in 2-meter EME or any sort of EME communication, you absolutely need to enable your equipment to run the digital modes flawlessly, no audio hum. What I would suggest to anybody is avoid interfacing your sound card through your mic jack if possible. Most of the radios today have a data port on the back. The ASUs do, the ICOMs do. Plug right from the data port in the back of the radio and plug it into your computer or into your interface and then your computer. I cannot emphasize enough on using snap-on chokes. Take RF off the cabling, especially if you're running high power. And of course, with weak signal work and with EME, in most cases, we're going to be running some high power. So if there's a little bit of RF floating around in the shack, you want something that's going to take that off the cables. You don't need any hum or feedback because that's just going to make you want to pull out your hair. Make sure, again, the signal is nice and clean. Use cables and connectors of good quality. USB cables that have chokes on them, although I even snap a few extra chokes. Again, picture on the right there shows the data connection that goes into the back of the radio and into your computer. Put some toroids and use shielded cabling. Don't let all kinds of loose cables flop all over the place. And that's not only for 2 meters or above, that's really for everything. Keep the cables as short as possible. The EME array itself, let's talk a little bit about antennas. We're going to, again, scratch the surface on all this stuff tonight and then in later segments dig down into it a little bit. The antennas on the right there are a local ham, K7ULS. He lives up in Eden, Utah. And Mike has had very, very good success with 2 Yagis and working quite a few people. On the right side of that picture, it's a little hard to see, but he's got a 5-element modified Cushcraft antenna, and he is also working 6-meter EME with very, very good results. Okay, antennas. You talked about antennas before. There's a lot of different theories, but this is kind of what I subscribe to. For you to have success for 2-meter EME QSOs on a regular basis, and again, there's a lot of factors out there, I would say you need an antenna that's going to provide about 15 dB of gain. The amount can be achieved by 2 horizontal stacked Yagis with probably 13 to 16 foot booms. A single Yagi will require a boom of about 24 feet to achieve true 15 dB of gain. But again, people are also having success with 9-element antennas and even smaller. I'm just putting that out there as a little bit of a standard point, a little bit of a starting point. I would say the most important thing is a well-designed Yagi, without a doubt. This gentleman, G0KSC, Justin owns Innov Antennas in the UK. If you want to build your antennas, Justin has many, many designs on his site. He has all of the plans and everything right there for all of his antennas. The spacing, the size tube that you need. And I'm going to tell you something. I've worked with Justin. I actually own some Innov antennas for some different bands. I can't say anything but great things about him. He'll get back to you in an email note, even if you don't buy nothing from the guy. If you say, hey, look, I'm trying to build this 15-element Yagi for 432 or 222 or whatever it may be, he's more than willing to help. I just cannot say enough good things. He doesn't hide anything. He shows you the spacing, tells you what parts you need, and you can save a considerable amount of money if you want to build the antennas yourself. Tubing is available out there. There's a lot of online places, and a lot of the big ham stores also carry it as well in bulk. So if you've got a good saw and a drill press and you don't mind putting it together, it's a sense of accomplishment, I think, without a doubt. If you don't have time to build the antennas, of course, you can go to his website at innovantennas.com, and he sells all of his antennas. Everything is fairly priced. He prices very fairly for shipping from the UK to the United States. At our station, at the moment, I run a pair of M-squared 2M12 Yagis. They're 20-foot booms. They're stacked together. Get about 12 dB, 13 dB on one Yagi. By putting the second Yagi there, we have 3 dB. So I'm at about 16 dB, and I've had pretty good success with those antennas. Those antennas are put out by M-squared. M-squared has a whole line of antennas, and Mike Stahl, who was one of the founding people of KLM, has been around forever. Mike will do anything to help you out as far as to get your station off the ground. Just a great guy all the way around. High gain, when we had the conversation a couple weeks ago, Tom, with Martin, G0KSE Justin has stepped in and helped High Gain, and I believe Cushcraft developed some of the LFA technology, antennas and spacing, and I know that he's stepped in and worked with High Gain, and I believe Cushcraft as well. I think Cushcraft's coming out with some new stuff. So again, there's a lot of opportunities out there, a lot of different antennas. I would say that optimum performance using well-designed Yagis is really, really key. Antennas that are built with using programs like EZN EC Pro 4, which Justin uses, they're all computer designed Yagis, they're all modeled. Again, the antennas have kind of changed over the years. I remember years ago it was like longest boom you can put out there and as many elements as you can put out, and that's really not true anymore. Guys like Justin and many others are going out on a limb and they're playing with the antennas and doing a lot of different modeling. Now we're seeing reflectorless Yagis, Yagis that don't necessarily have a lot of front to back, but better side to side. And of course, the LFA definitely knocks down the noise with the loop feed, the loop feed, a shorted loop, and even what they call the op-des antenna, the opposing driven element system. A lot of new stuff that's coming out, and these antennas are just performing astronomically. Old school Yagis, like the old F9 FT down there at the bottom, I had those for years. They work too. If you look at the antenna, every element is the same. They're all spaced the same. I made a lot of contacts with mine over the years. They work, but again, old school technology before we had all these different design programs. Let's get back a little bit and talk about our friend Spacial Polarization and talk a couple things around this topic because it's definitely something that's out there. Again, some challenges are polarization. Spatial polarization offset is your horizontal is it my horizontal, or consequently your vertical is it my vertical. And then we also have Faraday rotation as well. Many times during an EME contact, there's effects like Faraday, which basically turns the polarization of an EME signal around by up to 90 degrees. Sometimes this can last for hours, sometimes this can last for days. If you're able to switch the polarization of the antennas by 90 degrees, you can sometimes get around this. A lot of people are now putting up cross-pole Yagis or X-pole Yagis, and they're able to switch back and forth between vertical and horizontal polarization. It's an example on this little drawing here. On the left-hand side, there's an X-pole antenna that's got, I think, 12 vertical elements and 12 horizontal elements. You can switch polarity. And if you look at the little picture on the right, it shows the moon. We're on the west side going up on the receive. It's vertical and coming, or it's going up horizontal and it's coming down vertical. So again, switching polarity can make a huge difference. I have 2 horizontal Yagis. My goal next year or the year after is to go to 4 cross-pole antennas. And that's what a pair of them looks like. But now you've got to contend, with some other factors like feeding and relays and different things to change polarity. There's the moon. We see it up in the sky. We can point at it. But now we've got to rotate the antennas to get it up there to have the antenna point at the moon. So, of course, that's something that you have to consider too in your budget, is that you're going to need an antenna rotator that has elevation control and azimuth control as well. Probably one of the most popular ones, Tom, I think you've got this, is the Yaesu 55-5600 that's able to turn the antennas up and down and side to side. This is a great rotor. It's been around forever. It has a computer interface port on the back you can plug into. And believe it or not, this rotor will handle, fairly decent size EME array, as long as you don't have elements that are, booms that are way out there. But it's a real decent rotor. Or again, back to our manual pointing. If you want, you can see the moon. You go out there, you tilt the antenna up. Many people are using portable setups where they're doing everything manually. You put a little protractor down on the bottom. You can drop a line off of it, and you can also figure out the elevation looking at the compass down at the bottom.
Pat, let me ask a question
Sure.
here. I mean, first of all, the moon does not move like a satellite. You know, when we work satellites, we have 7 minutes, 8 minutes, 9 minutes, and we have to follow that satellite. The moon's pretty much in the same spot. I know a digital contact takes a couple minutes, but I wouldn't think the moon is going to really move out of that in 2 minutes. It's going to move too much. So I don't think you're going to have to constantly be adjusting the azimuth or elevation, are you?
No, and about 20 minutes is what you've got. Now, again, that depends on where the moon is at, of course, whether it's at perigee or apogee. But I've used manual control for a long time. The automatic is nice because if you want to sit there, like if you're going to work the EME contest, you got enough going on with logging and getting things set up. It's nice to have automatic tracking. But no, I would say 18 to 20 minutes you need to move the antennas around. It's not like a satellite or like these LEOs that fly overhead and you're almost better with a pair of egg beaters than trying to follow.
Well, and another thing, I've got azimuth elevation rotors out there I'm going to use for satellite, but the accuracy of it, I don't think, you could be off a couple of degrees easy with that thing, and at the distance of the moon, a couple of degrees could be quite a ways off your target. So my plan is just to take that long Yagi down, set it down on a tripod on the ground, and basically, look through that boom and line up the moon through it there, and that way I pretty much know I'm aimed at the moon.
You can, or let me show you a slide here, which I've done in the past. In the past, this is just another quick mount. If you don't want to buy an azimuth rotor, an elevation rotor, a lot of guys have used the old TVRO actuators. You can find them on eBay for next to nothing.
Yeah.
And build your own tilt mechanism. Use a couple of encoders, and then again, here's a little setup here, a little homebrew setup that actually runs the rotors with a little Raspberry Pi. There's quite a few different people out there that have source code you can download. I've got a lot of equipment. I haven't built any of this up yet, but you can do it. Or this is one of the track boxes you can buy by EA4TX. I've seen one of these in action. Amazing tool. You plug your Yaesu rotor into it. It's got the moon already, the keps for the moon already put in it because the keps never change for the moon, and it'll follow the antenna. It'll move the antennas accordingly. Or this little guy here, an inexpensive video camera. That's what I had. I've got up right now. My antennas are down at the moment. I use that little cheap Amazon camera. I found one that had crosshairs on it, and I put it off the side of the boom, and I just moved it until the crosshairs lined up on the moon, and it worked just fine.
Oh, I like that.
So
I like that.
yeah. Now the only problem is though, this slide shows if the clouds are in the way and if the moon disappears or it's, cloudy night. But this little guy works just fine. I've tried a couple of different ones. I was a little concerned about getting noise, if they create hash noise or something, but they never did. They work just fine. So that's another route you can go. The boom, looking through the boom, if you got a 20-foot, 15-foot boom, I don't know, it may curve enough, but you can get in the ballpark.
Yeah, it's got a little curve. This beam I've got it's their 14 element. It's 15.8 feet long, and you can see it's got a little curve to it.
And you could take that out with some truss wires too if you wanted to straighten it out a little bit. But I will say that at least on 2 meters, not on 1296 or above, or even probably 432, you get in the ballpark. And of course, the software also, Tom, has what we call ping mode. So you can actually ping the moon and signal up, and if conditions are right, and hopefully everything is working the way it should, you can ping back and forth. And I've played with that and moved the antennas, and I've peaked and stuff. Again, you're talking at sub-level, way below the noise level stuff. It's just amazing that it even works. But
well, and hey, if I could just do a ping and see the signal come back, I knew I bounced the signal off the moon. That's in my bucket list, to bounce the signal off the moon. And hey, just real quick, guys, if any of you guys watched The Big Bang, do you remember when they shot the laser at the moon? Any of you guys out there? Well, they were up on the roof and they shot a laser at the moon, and Penny's boyfriend says, how do you know you won't explode the moon? Okay, back to the show here.
So let's go on a little bit with tracking the moon. If you don't want to go out and look up the tube, or if you don't want to put a camera out there, there's quite a bit of free programs out there. One that I've used is this one here by F1 EHN. You can go ahead. This one will actually control rotors. Depending, I believe there's quite a few radios it will plug into, and it will also take care of Doppler for you as well. So you can really automate your station. But like you said, that's a key point, Tom, is that you've got to have it set up right the first time. If you go out there and you have everything set up and you put your boom through the rotor and you go, yeah, that looks about right, it's got to be really right. It's got to be right on if you want the programs to work accordingly. But there's several freeware programs out there for moon tracking. Feeding the antenna. We talked a little bit a couple weeks ago about coax and feed line. We'll just kind of run through it really good on cabling. I cannot say it enough. The transmission line has got to be decent stuff. If you're going to build an EME array and you got some old RG8 out in the garage or whatever, well, keep it for a dipole or whatever. You need good transmission line. I would say half-inch hard line would probably be the best. If that's not in the cards, an LMR 400 type of cable or a 9913 will work pretty decent at 2 meters. Plus, you can put a lot of power through it. But hardline, Helix, you can find pieces on eBay all the time. You can find it very affordably. I've got a bunch of hard Helix over here that I picked up used. Just made sure it ain't kinked up or nothing like that. It's out there. If you can afford it, or again, search it down, it's definitely the way to go. Again, you want to get the best lowest attenuation feed line you can for feeding your EME array. Make sure your feed line's as short as possible. And it's especially true if you don't have an RX preamp up at the antenna. We're going to get into that in another show. But again, don't be shy of investing in a good feed line. I would say that a good antenna and good feed line are probably the two of the most important things. Again, here's some of the numbers, and they don't lie. I got cut off a little bit, but I know some guys talk about, well, I use some RG8X. Well, at 100 megahertz, you lose 6 dB. You can't afford that. It just doesn't work there. And again, leaky cable. If it's leaking, if it's got kinks in it, if it's the shield's falling apart or whatever, it means less power delivered up to the antennas from the amplifier. All right, let's talk about getting the signal to the moon. We need an amp, without a doubt. A couple of different ways to go. Mirage, I believe, is distributed through Ameritron. You can get a plug-and-play solid-state amp. This is one that's 50 watts in, 300 watts out. Beautiful amplifier. I've got an older version of this that I've used in the past, and it works fine. Of course, it needs a large DC power supply, so you got to take that into consideration. If money is not an object, K1FOs, lunar link systems, these are the Mercedes-Benzes of the VHF and UHF amplifiers. They run a pair of 3CX800A7s. Sadly, Steve left this years ago. He was an EME pioneer, but lunar link systems are still being made. But when you go look at the price list, you'll be like, yeah, they're nice. But again, some of these amplifiers, lethal high voltages. You got to be careful. Just like your HF amp, same thing for the VHF amps. Probably the best bang for the buck are the pallet amplifiers, the LD Moss pallet amps. They've come down in price. The components have come down in price. You can find them on eBay all over the place from many different countries. You can get a kilowatt for probably about $2 a watt, an easy 1,000 watts. And again, they're coming down all the time. We'll do a show and a segment on these amplifiers as well. I've built a few of them and put a few in service. Again, they're going to give you the punch that you need. I would say 300 watts is about right. You probably can do it with 150. Key thing here to talk about is the TX periods are 1-minute sequences with JT65. Delivered at full power out, very similar to FM operation. So you've got to have your relays, your transceiver, your amplifiers, power supplies need to be able to cope with this amount of power and runtime. It's like putting your solid state amp in high power on FM and keying it. It's got to be able to hold up for 1-minute sequences. So a minute on, a minute off, a minute on, a minute off. Cooling is definitely key, without a doubt. Piece of ice there with the fan for sure. Your station's output is also your responsibility. Spurious signals are not good. If you've got a homebrew amplifier, and again, we'll get into that as well, you don't want something that's throwing spurs up and down the band all over the place. A good low-pass filter is needed to keep your signal clean. Kind of moving up and wrapping on, let's hear Kitty here a little bit better because Kitty Cat can't hear us. And kind of like the 3 letters of my call, a low noise preamp is really a necessity. An LNA is an electronic amplifier that amplifies very low power signal without significantly degrading its signal to noise ratio. A good LNA will increase the signal but keep the noise floor low. Sometimes people go out and they pick up a preamp that's not tuned properly, and they go, wow, the signal's sitting at S9, but so is my noise sitting at S9. You want something that's going to raise the signal and drop the noise or keep the noise floor as low as possible. You need an effective LNA for EME, without a doubt, something that has at least a noise figure less of 1.5 dB, probably somewhere upwards of 23 dB of preamp. Again, it can be mounted in the radio room as long as you use short, low-loss feed line. Putting the preamp up at the antenna makes a world of difference, but again, there's other considerations that you have to consider when you put it up at the antenna. Here's a couple of examples of some preamps. They're very small, they're very tiny. These preamps here, you do not transmit through them. They cannot take any power. You put in, you key the mic, bump the mic, poof, you'll pop it. That's it, it's over. So they have to have relay switching. Again, mass-mounted preamp is the best thing to do. We'll get into that in different shows and talk about the best way to do that. My setup is right on the right there. That's my exact setup. I use a couple of high-powered relays. I use an LNA technology preamp. I use another relay that actually takes the preamp off to a 50 ohm load while I'm in transmit mode, so I don't take a chance at popping the preamp. One on the left there is kind of a turnkey one. You hook up the antenna, the transceiver, and you run 12 volts. And some of those actually they have either a keying circuit in them or they're Vox operated. A sequencer, of course, is going to be needed as well to sequence the preamp in and out of line. You can buy an expensive one or you can buy an inexpensive one. I've bought several out of Russia that have worked really well in the $25 range. So they actually sequence to open the relays before the radio can transmit and then throw the amplifier in line. Again, if you've got your preamp up at the antenna and it's the middle of winter and you blow the thing up, most likely you're going to be done until the snow melts off the roof or till you get back up the tower. Sequencing for safety, again, it's very important that you switch things in and out of line. And again, we can get into that in more details in another show. And yes, this is a picture of something I did. I blew one up one time. I thought I could manually sequence, and well, the preamp popped and kind of cleaned the board right off. They don't like static either. If you're handling a preamp, make sure that you're not sitting there rubbing your pants or walking around with your socks on the carpet. Those gas feds do not like static at all. All right, let's kind of, in wrapping things up, appreciate everybody's patience. Can we work each other via EME? There's some great sites out there. EA6VQ has a calendar site that is updated for the entire year, for the weekends. This is just a little cutoff of it. It's at dxmaps.com, EME calendar. He updates this thing constantly. He'll give you the best moon conditions, your best chances of being able to work. When we have new moons, when the moon's at perigee, when it's at apogee. Very, very comprehensive website. Again, can we work each other? He has a moon bounce calculator. You put in your call, and you put in the person's call you want to work. Let it calculate it out, and it'll tell you yay or nay, and it'll also give you where the moon is at and when's the best time, when it's going to work best for both of you. In some cases, again, you can see the moon, but the person you want to work cannot see the moon. Where's everybody at? If you want to give EME a try, Pin Jockey is the place to go. There's the website for it. You can go to the JT65 EME link. It's pretty much when the moon is there. Matter of fact, we've got okay moon conditions tonight. Pin Jockey is actually active right now. You can go out and you can schedule skeds right there as well. There's some other sites. I'll provide a set of links and some descriptions that we can put out there where you can go take a look and have some live stuff. A great thing to take a look at is this is K2UIH, his site. Go out there and take a look. He publishes the 432 and above EME newsletter on a monthly basis. Even though we're talking about 2 meters, you can sure learn a lot of different things from what Al's done. Al Katz has again been a pioneer in UHF EME. And on the mornings, on Saturday and Sunday mornings at 9 a.m. Eastern, there are EME nets. There's an EME net on 20 meters at 14,345. It's not as active as it used to because everybody's able to schedule right online. There's really not a need to get on the air, but you will find quite a few people out there that are just chit-chatting or talking about setting up some scans. And if you go to QRZ.com, if you see that little box there with the solar image of the sun, go take a look, and you can see if you've got, I believe if you have your call sign in, it takes a look at it. I'm not 100% sure, but it'll also let you know if there's a chance, if you've got decent moon conditions. A typical exchange, and kind of wrapping this whole thing up, is, again, we talk about running 1-minute sequences. So there's a typical exchange. I would be calling CQ. Tom, you'd be coming back to me with your grid. I'd come back to you with my grid, and over. You'd come back to me with Roger over. I'd come back to you with Roger, and then 73s. It's 6 steps is about what it takes. I'm not going to go into the politics of it. Some guys do it in a little bit less, and they're sitting there kind of in the chat rooms and what have you, but I think it's a feat and a miracle almost if you can work each other. But there's the typical JT65 exchange. Is the calls in the grid, and they're over in the Roger, and then the 73. Let's just do a little reality check to kind of wrap this whole thing up tonight. Noise is a huge challenge. You've got your local noise. We've also got galactic noise. The moon is in front of the Milky Way 3 to 4 days every lunar month, and that background noise raises 6 to 8 dB. So during those days, if you can't work anybody, hey, that's a good time to improve the station. Doppler, of course, is something we've got to contend with because of the relative motion between the Earth and the Moon. It's about 300 hertz of tuning at 144 meg. Sometimes you have to kind of tune accordingly. because again, you might just be a little bit off from each other, and these digital modes do require that everybody is right on track with each other, not only on frequency but on in time as well. K1JT has come up with something called MAP65. It is a panoramic polarization matching receiver for JT65. We'll get into that in another session. This is kind of a little sketch with it. You can actually use a second SDR receiver, and the program actually does some tuning and moving for you. If money's not a problem, LinkRF puts up this beautiful dual-channel EME receiver that's set up to work with cross-pole Yagis and mute one receiver and change back and forth. They're expensive. I've seen it in action. It's very cool. It's on my Christmas list one of these days. Again, there's the cross-pole Yagis where you can switch polarity. That's kind of the size array that I'll be moving to next year. I'm in the process of actually building a new crank-up tower. Hopefully I'll get it done by the springtime. Again, Faraday is something that we've got to deal with, but the X-pole can help that. The cross poles can definitely help that. And it all takes time and effort. And you know, some months it's good, some months it's not good, but it's a challenge that's really enjoyable. So I've done a lot of talking tonight. Hopefully I haven't bored you all. I've gone over a lot of different things, but I still think it's really, really cool. If you want a little bit more reference, you can go out and find the ARRL conference proceedings. They're out there and available. And something that I've never been to, but every other year, is an EME conference just about a couple months ago, in the Netherlands. EME 2018 occurred, and all the EMEers went there, and it's just an unbelievable thing that happens. It's held throughout the world. Coming soon, we'll talk about different things. We'll talk about antenna design and building, about assembly, mass mounting preamps, amplifiers, operating with JT65 setup. I'm trying to put something together with some guest EME operators that can come in and talk, and we'll see if we can do a live EME QSO. Actually, tonight I ran the calculator. If I was set up to go, we might have been able to do that. But otherwise, I would like to thank you for sticking around and listening to all of that, and I hope that in some way, shape, or form, I was able to at least enlighten you and have your interest come up.
Hey, this is really exciting, and let me tell you, a couple of things I've just learned is that we're doing it kind of on the low end, or I'm going to do it on the low end. You know, single Yagi, a little bit of power. Going to have to use a digital program like JT65B, I think. But
right.
Hey, if I can get a signal to the moon and back, I don't care if it's sideband, CW, or whatever. So if I can just do it, and I like the fact about the ping deal where he's built in now, where you can actually send your signal and see it come back, and that's cool. You know, when you work in satellites, you can hear yourself, and you can turn the polarity of the antenna to get the best you know, noise to signal level, and you can, you know, very quickly with your hand, you know, tune in a satellite with the antenna, tune in the best polarity. With this, I'm not going to be able to. The antenna is going to be fixed in a certain plane, vertical, horizontal, who knows. And you're right, what's my vertical may not be the vertical on the other end, because, hey, it's going to change. It may, you know, who knows. But, you know, one of the things I did learn was that to do it as a small station, it's going to be pretty tough to make a contact with another small station. And what I'm learning here is that you need a big station at the other end. You need one of the guys that are, you know, running the big antenna arrays and the high power. If you got a big gun on the other end, you got a pretty good chance of maybe having a QSO with that person. So we're going to see how it turns out. That's something that I want to do.
Well, I think, you know, and again, you've got the radio, Tom. You don't need to go out and have the most expensive setup. Again, something like a 706 or a 7000. You know, any of these all modes, a single Yagi, and yeah, you can pick up. You know, again, you don't need to go out and spend a ton of money on amplifiers. But I think once you get into it, you get the bug when you hear your echoes the first time, or you see that ping come back, that's really going to enlighten you without a doubt. And that's where you kind of go, all right, this is cool. I was able to do it. Now I want to be able to do it more. And even the big stations, it's not a guarantee. There's a lot of different things that come into play. But the small state, there are also people that are working single Yagi to single Yagi when you have really, really, really good conditions. But yes, working a bigger station is pretty decent. My station eventually next year will be four pole Yagis, and I can produce 1,000 watts without a problem. And I would say I'm not a big station by any means, but I would say I'm mediocre, and I have a pretty good shot at it. Mm-hmm. I've done very well with just 2 Yagis, though. I've done extremely well.
Okay. Hey, I did put the phone line up here, 901-286-1116. I know it's getting pretty late. We'll open the phone lines for 2 or 3 minutes here. If anybody wants to call in, you're welcome to give us a call. But yeah, hey, that's a good segment to get us started. People in the chat room are asking, can you get a copy of the presentation? I don't know if you've got it on your site or anything, or.
I don't, or maybe we could load it up on your site or put it somewhere. I do have a Blogspot site. I can get it loaded up on there during the week, and sure, and we can kind of use it as a working document. Again, it was more for talking points, but. Again, I hope it sparks somebody's interest. I love it. I have a passion for it, and it can be frustrating, but it's fun.
Yeah. Okay. We'll see if we can't get that up here now. And as Bill mentioned in the chat room, of course our show is recorded, so a person can go back to our YouTube channel and pull the show up at any time, and can actually fast forward to the presentation there and watch the entire presentation again, or put it up on a big screen, or whatever they want to do. So you have our permission to use it if you want to.
Yep.
Yeah.
Yep.
Okay.
And if you want to send me an email, it's k7lnp@centurylink.net. That's the email off of my QRZ page. I can also send it to you that way. The file is not actually it's not too big.
All right, just checking here. Still, phone line's still open. 901-286-1116. So, all the way down to maybe even possibly at some point scheduling a live contact during the show. That'd be kind of cool if we can do that. Yeah.
Yeah. What we could maybe do is get something set up with somebody else, and I also have talked to a few other seasoned EMEers, and they would be more than willing to come on the show. And maybe we'll see if we can even reach out to Joe Taylor and see if we can get Joe on the show.
Yeah, it'd be cool to get Joe on. One of the things that I wanted to also mention was there is a little danger here, especially running semi-high power. If you've got other, am I buzzing here?
That's you.
Yeah. If you've got other 2-meter radios on an antenna, it's very possible it could pick up your high power signal off the other antenna if they're close, and it could do some damage to your 2-meter rig. And I only say that because as I've been playing with these remote shacks and remote bases over the last year, I left the antenna on my TS570, even though the radio was turned off. That was my remote shack rig. Even though the radio was turned off, the antenna was still hooked up. And I called the 40-meter net here one Tuesday night, running a kilowatt. Well, the antennas out there are probably in the remote base is on a dedicated antenna, but they're probably not 20 feet apart. And it picked that kilowatt up, brought it back down into that 570, and it actually burned a hole about the size of a dime in the circuit board. I was able to go in and repair it. But since then, and people do know this, I built up a little accessory that when the remote check is not on or used, it automatically disconnects the antenna. But that just might be something we have to think about on VHF. I'm not sure if 300 watts could damage your receiver, another 2-meter receiver, if it had another antenna, especially an outside antenna on it and they were close. But it could. So, man, there's a lot to learn here.
Well, and you also have to remember too that you're at you're at 144 meg, and you've got, let's say, 20 elements up there. If you've got a pair of antennas or 25 elements with several hundred watts, that's generating a lot of ERP power.
Yeah.
You've got to also consider that. That's why in the with my preamp, my mass-mounted preamp, when I move to transmit mode, when we sequence over to transmit mode, I have another little relay that kicks in and it throws the preamp into a 50 ohm dummy load, essentially. Again, something that we'll talk about in future shows about, good relays that have high isolation.
Yeah, and I don't think I'm not going to set EME up for regular usage like you use it throughout the year. I'm not going to do that. I'm doing it more for an experiment for the people on the show to show it can be done with less equipment. So what I'm going to do is I'm going to take my 15 or element Yagi down, put it on a tripod down on the ground. I'm going to go down to MFJ and make Martin give me one of those 300 watt. Well, he won't give me. I'll say, Martin, I want to borrow it. Give me a 300 watt amplifier. Mm-hmm. That amplifier going the other way, so it will amplify the receive signal some too. So we'll mount that 300 watt amp outside at the antenna. You're right. It's going to take a large power supply. I don't know what a 300 watt 2-meter amp draws. Probably 30 amps, maybe.
Yeah, I would say you'd want to use like an Ameritron 50 at least.
Yeah, and I don't have that Ameritron 35 here. I mean, I've got it's not Ameritron. What is it? Is it Ameritron? No, it's I've got an Astron. Astron, yeah, the Astron 35. Or something, maybe, we can get creative. But the thing is, we're going to have to put a large blower fan on that sucker and let it run full blast during that contact, because, key down 300 watts is it's going to get pretty hot.
For sure. But yeah, a car battery would work out really good, and you can even set it up on a portable basis. Take your radio out. In future shows, I've got some links I can put out. There's a gentleman on the East Coast with a 12-element 432 Yagi and 100 watts and a 991, made a couple of 432 EME contacts with 12 elements. I was blown away. So
yeah.
Now he worked, again, big stations, big antennas, dish, what have you.
I'm excited about the ping part here. If I don't even talk to anybody else, if I can just, do the ping, yep. I'll have a big smile, man.
Yep.
Okay. Good presentation and a good start off of our 50 megahertz and above segments. And we'll continue this.
We will. And again, the things that we talk about, again, can be used for satellite work. They can be used for weak signal work, for tropospheric work, for meteor scatter, a lot of stuff. So you can use your EME array for a lot of other things.
Yeah. All right. Well, Pat, thanks so much for giving us that presentation tonight. Looking forward to additional shows to take this segment even further. Thank you, and we'll probably see you next week.
For sure.
We're going to go ahead and probably shut the show down here in just a minute. Let me bring the camera back over here on me. Guys, we thank you for joining the show tonight. And, hey, again, if you're new and you're still in the chat room, tell us. I saw one new guy tonight. Is it George? KN4NBE? I think he was new. and he may have checked in the net tonight. We've got the 40-meter net. Love for you guys to join our 40-meter net. It's every Tuesday night from 5:30 Central Time to about 7 p.m. Central Time. Join us and get to talk to all the other guys around here and us, and we'd love to have you check in. I'm also looking for volunteers. If somebody out there would love to call a Roundtable net, and they would love to call, say, 20-meter net or an 80-meter net on Tuesdays when we do the 40-meter net, I'd love to open the net up to a different band, because that will let different people, it'll let different people come into the show and into the net. You know, we'll be able to pick up and talk with different people than we will on just one band. So help us, and if you want to call a 40-meter net, I have no problem with that at all. That'll give me time to work more on the show for that Tuesday evening. Again, if you're listening on the International Shortwave Station, WBCQ out of Monticello, Maine, shoot us an email to Tom at W5KUB. That's Tom at Whiskey 5 Kilo Uniform Bravo.com. Tell us where you are and tell us how you're hearing us. Let's see what else is going on here. We got some Hamfest coming up. We'll be talking about. Hopefully Katie will be back with us next week. Katie took a couple weeks off to do a few things. Dave Kassler is engaged on Tuesday nights right now with his wife in some musical. I'm not sure what it is. We'll find out more about that later. So Dave hadn't left us. He's just busy on Tuesday nights, and he'll be back with us soon. Send your FCC questions to us, and hey, join our Facebook group. Just search for the Facebook group called W5KUB. Join it. We've got about 7,000 members now in our Facebook group. It's a ham radio site. Post pictures of your shacks. Katie or I or somebody will probably show your shack pictures on the show. Post questions. Just check in to see who's going to be on the show, and it's just a ham radio site to do anything ham radio related. So please join Facebook group W5KUB and help us get the word out either through Twitter and our Facebook to the rest of the world. We've got viewers in over 150 countries. We've drawn some very big crowds, like during a Dayton Hamvention, we've had as many as 50,000 people tune in over about a 5 to 7 day period. But you know what? We don't have many people that tune in on Tuesday nights. And I can go here to Memphis Field Day and say, do you watch a show? And probably 8 out of 10 people, local people, don't even know we got a show. So help us spread the word. Email it, put it on your Facebook, share it on Facebook groups and so forth. Okay, guys. We had good weather tonight. We're supposed to get severe weather in here tomorrow, and that's always fun during the show when you have severe weather. The internet goes out, the power goes on and off, so we lucked out tonight. Good night to everybody. 73. We'll see you next week.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
All right. Well, it's not going to last like that very long. In fact, pretty soon I'm dreading this, but this is probably what it's going to look like out the window here. No hangout tonight, Douglas. Well, we ran late. No hangout tonight. So good night to everybody.